Welcome to this Masterclass Explainer. Today, we're crossing a major threshold in your capstone journey. We're going to transition your mindset from simply finding a root cause for a societal problem to rigorously defending a data set that actually proves that problem exists. As your professor today, I really need you to start thinking like a forensic data scientist. Listen, a data set isn't the right one just because it was the easiest one to pull off a Google search, right? It's the right one because your group can scientifically defend it. Let's get started. We've got a packed syllabus for today's explainer to get that capstone ready. We'll start with the foundations of defensible data, move into sourcing and the Q1, Q5 test, then tackle naming and taming bias, break down the three-link impact chain, and finally, stress test your predictions. All right, part one, foundations of defensible data. We're looking at the dataset, source, and sample. Okay, let's dive into this. Before you can source or assess any information at all, we have to establish the absolute foundational terminology. Every completeness, credibility, and biased judgment you make in your capstone assumes you can clearly tell these three concepts apart. So first up, the data set. This is the tangible thing you're actually working with. It's the full collection of records you'll analyze. Its rows, its columns, and crucially, the documentation describing them. Think of a CSV file containing household internet subscriptions broken down by census tract. That file, the whole shebang in its entirety, that's your data set. Next, we have the source. Now, a data set doesn't just magically appear out of thin air, right? It comes from somewhere. The source is the organization or system that collected and published it. We're evaluating its authority, its funding, and its methodology. To continue our example, the U.S. Census Bureau, which publishes the American Community Survey, that is an authoritative source. And finally, the sample. This is where academic rigor really matters, folks. The sample is the specific subset of a population actually captured in your dataset. It is almost never the entire population itself. If we look at survey data, your sample only represents the households that actually took the time to respond to the survey, not every single household in that census tract. Remembering this distinction, it's going to save you from making massive analytical errors later on. Moving on to Section 2, sourcing and the Q1, Q5 test. Vetting your candidates. Let's get into the actual methodology of sourcing, and I'm going to challenge you right now. Never, ever settle for the first data set you find. Seriously, finding data is easy, but finding the right data, that requires serious vetting. So where are we finding these candidate data sets? We generally look at four main categories. First, government and open data portals like data.gov. These are usually your most authoritative starting points. Second, academic and research repositories. These offer fantastic, peer-reviewed data with highly transparent methodologies. Third, institutional and API sources, places like the FCC, the Bureau of Labor Statistics, or the CDC. These are an absolute lifesaver when recency is vital. And fourth, community and nonprofit data, which honestly is often the only place you'll find true lived experience or hyperlocal context. Now here's the golden rule for your capstone. You must pull at least two distinct candidates from different categories. Why? Well, because a single source literally cannot cross-check itself. Once you've got your candidates lined up, you have to treat them like suspects in a forensic investigation using the Q1, Q5 evaluation framework. We used this back in Module 4 for problem statements, but now we're turning it directly on the datasets. Question 1, is it accurate against other sources? Take a second, actually verify it. Question 2, is it complete for your specific population and time period? Moving to question 3, is it contextually right or is it just some generic aggregate? Question 4, is it verifiable enough that I, your professor, can actually trust your numbers? And finally, question 5, is it biased or limited? The dataset that survives this intense interrogation is the one that proves your root cause. Let's look at a classic capstone example to illustrate this brilliantly. Closing the rural broadband gap. We've got two candidates here. Candidate A is FCC Form 477, which reports where internet providers claim services available. Candidate B is the American Community Survey, tracking self-reported household internet subscriptions. So candidate A shows advertised availability, while candidate B shows the actual reality inside the home. One is the root cause, lack of infrastructure. The other is the symptom, unconnected households. Now, you might be thinking you have to pick the best one, right? Actually, no. Defending the data sometimes requires you to be intellectually flexible. In this specific case, the selected choice is both, paired together. The FCC data substantiates the root cause, that no service is physically available. The ACS data substantiates the symptom, that 34% of households are unconnected. Neither dataset alone tells the full causal story, but paired together, they form an absolutely airtight defense. All right, part 3, naming and taming bias, completeness, credibility, and limitations. Now that we've sourced the data, we have to inspect your chosen dataset for structural integrity before it is allowed anywhere near your final capstone project. This means running rigorous completeness and credibility checks. We look at coverage and missingness, like are 30% of your crucial rows just sitting there totally blank? We look at methodology transparency and peer review. And please, I'm begging you, use some common sense regarding temporal currency and granularity. Don't be that group that uses a 10-year-old state-level average to justify a highly specific claim about a local neighborhood today. It's an amateur mistake, and frankly, it won't pass the review panel. A massive part of that structural integrity is acknowledging bias. Every dataset has bias, period. Your job as a computer scientist is to name it, not pretend it doesn't exist. Consider this your cheat sheet. Selection bias systematically excludes people, kind of like a phone survey missing households without landlines. Historical bias reflects past systemic inequities. Think of policing data showing where officers were historically sent, not necessarily where all incidents actually happen. Measurement bias. That occurs when definitions differ, like self-reported income versus actual verified payroll. And reporting bias happens when the people who choose to respond differ fundamentally from those who don't, such as an online survey systematically undercounting people without internet access. You've got to name the bias in your data. So the crucial point here is incredibly simple, but so important. A named, documented bias is a defensible limitation, not a flaw that sinks your project. In fact, documenting your limitations is the absolute hallmark of true data integrity and academic rigor. Let's move into Section 4, the 3-link impact chain, gating the IGS claims. We're going to shift our focus slightly to the Inclusive Growth Score, or IGS. Specifically, we're looking at the metaphorical gate that blocks completely unsupported claims from entering your capstone proposal. To get an impact claim into your proposal, it absolutely must pass through the 3-link impact chain. Link 1 is evidence. You have to start with a verified figure from your fully vetted dataset. Link 2 is the mechanism. You state the precise, specific way your prototype actually changes that figure. Only then do you reach Link 3, the IGS claim, a resulting, tightly scoped claim about inclusive growth impact. Let me be clear. Absolutely no claim advances unless it traces back through a logical mechanism directly to a verified figure. Let's compare these side by side so you can really see it. A weak, ungated assumption sounds like a generic pitch. Something like, our tool will improve internet access and boost inclusive growth. It has no mechanism, no concrete evidence, no specific scope. Now compare that to a strong, airtight academic defense. By prioritizing the 2,400 residents in this census tract currently unconnected, per USDA and FCC data, our scheduling tool is expected to reduce time to service by 40%, directly moving the digital access subscore. You see the difference? Evidence, mechanism, targeted claim. Which brings us to Section 5, Stress Testing Predictions, the final exam for long-term effects. We're nearing the end of our evaluation phase here, and it is time to load test the structure you've built. We're going to evaluate your solution's long-term societal effects by giving it a really tough final exam. We do this using the 4 diagnostic gauges from Module 3. We're going to deliberately try to break your prediction. Does it suffer from hallucination, fabricating statistics no dataset actually supports? Or perhaps bias, making rosy predictions based on generic training assumptions rather than local evidence? Are we seeing context collapse, where you've just kind of drifted away from your community's specific realities into generic talking points? Or maybe scope creep, where your predicted effect balloons wildly beyond what one prototype built in a single semester could ever plausibly cause? Okay, let's say your draft claim was that your new app will eliminate local unemployment. Well, that instantly fails the hallucination and scope creep tests. One app is not eliminating unemployment. But if we apply our gauges, we get a scientifically grounded revision. Something like, closing the broadband gap reduces residents' time to submit on remote work job applications, contributing marginally to the digital access subscore. Now that is a defensible, scientifically sound prediction. Before we wrap up, here is your final defense checklist. To cross the bridge into the data cleaning and visualization stage coming up in Module 6, your group absolutely must have done the following. Sourced 2 or more candidates and compared them. Documented your dataset's completeness and credibility, named and flagged its biases in writing, gated all of your IGS claims using evidence and mechanism, ensured your predictions survive our 4 diagnostic gauges, and finally, prepared a formal written defense of why this dataset was chosen. I want to leave you with a Socratic challenge as you head off to build your capstones. Really ask yourself, are you actually finding the truth? Or are you just finding the data that happens to agree with you? A truly defensible data set demands rigorous honesty. Apply the standards we discussed today, respect the structural integrity of your data, and I'll see you in Module 6.